I want to add some health, I want to take some damage, add some mana, take away some mana, add some experience, get another level. Hello, thank you for joining me again for another video on Gum. I've been using it more recently. In this video, I'm going to cover strongly typed components, show how to create them, and finally, use them in Monogame. We covered strongly typed components briefly before. Quick reminder before we begin, Gum has two main parts, the Gum tool and the Gum runtime. The Gum tool is the editor that lets you build up a complex hierarchy of objects visually by clicking, dragging, and setting values. It gives you direct feedback visually by allowing you to lay out your design in real time. The Gum runtime is the NuGet package, or DLL file, that your game or project will need. It is the layout engine. So what is a strongly typed component? A strongly typed component, or screen, is just a custom component, or screen. It's a code file that can be generated so that you can use that class file in your Monogame project. How do you create a strongly typed component in the Gum tool? On the screen, you can see here that I've got the component up, and I've got it all laid out so we can see it. On the right side, there's a code tab. The simple answer is that we just click Generate Code. We're going to go into a little bit longer answer. To do that, I've created this component, which I'm going to go over now. First, I have the actual component, created by right-clicking and saying Add Component. Once I have that component created, I've added 4 different containers. These are just the standard container, standard element type of container. Each of these is designed to just allow me to lay out these objects from top to bottom using the children layout option of top to bottom stack. Then under each of them we have 3 items. Well, some just have 2 or 1. The health row has the health bar itself, 2 buttons for the demo, and inside the health bar container itself there's also a label on top so we can see the text of the value. So now that we have this custom component where I've laid out all the objects, I've written appropriate names for each object, set the values and placements how I like them, I can actually generate the component so I can use it in Monogame. Now let's generate the code for this strongly typed component. Let's take a look at some of the settings that you want to use to generate the code files. I'm going to take you through some of the settings that I like to use. So this will be a quick overview of the code tab. First, you'll want to click Is CodeGen plugin enabled and Show CodeGen preview. You also want to make sure that you're on the root component object. You can see here it's just showing the code for this label. I want to be on the root component so that I can see the whole code and make sure I'm on the right object. This first button allows the Gum tool, along with some other options, to automatically generate your code file when you make changes. The Show CodeGen Preview button allows you to see what code will be generated into the file. So we can see here a preview of what's going to end up in that file. Now there's actually pages on the Gum documentation where we can see the code tab at a high level, and we can even see things that talk about is CodeGen plugin enabled, the Show CodeGen Preview. So each of these different parts of it are explained in better detail for you if you go out to the official documentation. The next thing is the inheritance location. The inheritance location here has 2 options, and this is simply where you want Gum to put the parent class that your component class will inherit from. What does all that mean? Well, if we look right here, there's container runtime. This container runtime is the parent class that character stats runtime will inherit all of its functionality from, its default functionality. When Gum generates a code file, it will actually generate two files. The first one is a generated.cs file, and the other one doesn't have the .generated.cs, and we'll look at those in a bit. My recommendation is that you put the inheritance location in the generated file, unless you plan to override the parent object, in which case you'd want to put that into the code, the custom code, so that you can change that at will. Next, we have the generation scope. I set this one to the selected object, and you're going to want to do that as well. Selected state would be just the values. So the word health potion, the -10, the 25, those values there. We don't really care about this state because we're going to be using find by name. I'll talk about that in a bit. And that will automatically pull in all of this data from our XML file. So there's no reason for us to have the state code generated. Instead, we want the object to be code generated. Next, we have over on the right, two main sections here, the project-wide code generation and the element code generation. Project-wide means it's for the entire project, not just this individual component or element. Element would be just for this character stats object. Under the project-wide generation, the first option you're going to want to change is the output library. We're going to select Monogame because we have a Monogame project. Next is the object instantiation. I'm going to choose find by name. This will make it so I can use the XML files of the project, the gumx files, and just load that directly from a file. This is the recommended approach. If for some reason you have some sort of input-output or loading constraints where you're trying to maximize milliseconds on your game loading, then maybe you would go to fully encode. But I would say until you find a need for it, just use find by name. Next, we have the project-wide using statements. If you have specific classes or libraries that you know you need to always include for all of your GUM classes, you can put them here into the project-wide using statements. They will automatically be placed at the top of any of the generated GUM class files. Next, we have the code project root. This is the location where your CS project file is located, the project file for your C# Monogame project. Not where the solution file is, but specifically where the project file is. Next, we have the root namespace. For me, for the demo project, I've called the project strongly typed components, and therefore the root namespace is strongly typed components. And I'll show that to you when we get into the Monogame. Lastly, we're going to jump past a lot of these other settings, leave them at the defaults, and I'm going to come down here to element code generation, specifically to generation behavior. I'm going to have this set to generate automatically on property change. This will make sure if you edit something in your GUM tool over here in your variables, in your settings, it will be reflected in the generated code file and generated and saved for you. Now that we've created our component in the GUM tool and we've defined all the parameters for generating the code, we're going to click Generate Code. We're going to accept all of the defaults for the pop-up, so we do want to generate all the other objects for now. That's it for the GUM tool. Let's jump over to Monogame. Over here in Visual Studio, I have a Monogame project. It's pretty plain. It doesn't do anything when I run it. We can see if we look to the right that I do have a components folder under the Solution Explorer. Under that is the custom folder, and we can see here is our character stats object, our runtime, and our generated files. The runtime is pretty bare. There's not much in it, but the generated file has all of the logic. Here's all of those different objects, the health percent bar, the experience percent bar, and they're all being instantiated or created down below. Now the first file here that doesn't have .generated, This one will only be created or generated one time. You won't be generating this file a second time. Whereas the generated file will be generated every time that you either click generate in the GUM tool, or if you're making edits in the GUM tool and you've configured it to automatically update the code. Now you'll notice that they're actually the same class. It's called a partial class, character stats runtime. If I go to the other one, partial class, character stats runtime. A partial class is a class that will be combined with any other partial class of the same name by Visual Studio during compile time into a single, full, complete class. Having these splits allows auto-generated code from the GUM tool to not overwrite your custom code that you write. So if you put custom code in here, GUM won't overwrite that code when it generates because it's going to use the generated file. Inside the custom code file, the only method we really have to override is just this one method, custom initialize. You can add code to this that will be executed when an instance of this class is created. Now that we have this, let's just display it on the screen as is, no functionality. The first thing that we need to make sure is that all of our objects are being copied to the content or output directory. So we have a content folder here where our project is saved. If you watched the previous videos, this is where you should save them. Inside of here is the gumx file. We can see that it's set to copy if newer for the output directory option. So copy to output directory is set to copy if newer. In the previous video, I showed how to open up your project file and change that setting so that it's actually everything in that folder and subfolders will be copied if newer. So you'll want to have this setting inside your project file. The main reason why is because I am using find by name, and so the XML files have to be copied to the output directory so that during runtime, the GUM runtime can find those files to load up the settings for this component. Next, we need to make sure the Monogame NuGet package is added. So we're going to go up to Tools, NuGet Package Manager, Manage NuGet Packages for Solution. I've already installed it, but you'll search here for gum.monogame, click, select your project, and install it. Now that the NuGet package is installed for the GUM monogame, we'll create a variable to hold a reference to our component. For simplicity's sake, I'm just going to call it root. That's quite often used when you have a screen or a more complicated structure. And remember, the name of our object is, if we look over on the right, character stats runtime. That's the name of our class. So that's the name of the object, the variable type that we're going to be making. Next, we need to load up our project. And to do that, we're going to put some code down in the initialize method here. Put the location of where your gumx project file is. And if you followed the previous tutorials, it should be under content, and then under a folder under content should be your actual GUM project folder. Under that GUM project folder will be your GUM project file. So whatever you called yours, make sure you match in your initialize method here. Next, we need to actually update all of these GUM objects. So down in the update method, we're going to add a call to Monogame GUM's update method. And we're going to pass in this root object so that it gets updated whenever the GUM runtime does its updating. After that, we're going to draw. So we need to make sure we call the draw method for GUM. Now, if we do this by itself, we don't add anything more, there's nothing going to happen. And that's because we haven't actually loaded root yet. Root is still null. It's an empty object. As we can see, nothing is showing up. So now in your load content method, we're going to add two things. The first is we're going to create an instance of our object. So root equals new character stats runtime. And then we need to add it to the managers. We need to tell Gum to pay attention to this, to do it for the updating the drawing, things like that. So we're going to do those two now. At this point, we can run our program. So let's go ahead and run the program. And now we can see we have our strongly typed component in code. But if we look at the buttons, even though I'm using Gum forms, it's not doing anything. And what I mean by that is if we go back to the Gum tool, when I first created this project, I actually went to content and can't see it anymore, but I installed Gum forms. We have the objects being displayed in Gum. They appear to be interacting. We can hover over, we can click on the buttons, but nothing is happening. There's no code defined that does something when we click a button or tells the health bar to update. So now we need to wire up that functionality. So let's see how to interact with and enhance a strongly typed component. How to wire this functionality up. We're going to create some properties on the component that will change the values in the component. So we're going to go to our runtime. This is the not generated one. We don't want to touch the generated file. And so what I want to do is let's run our project again. I want to store our health, our experience, and our mana. And I want to do that in a way where we can easily interface with those stats, make changes to them, and use them in our game. Before we go much further, I'm going to add these two lines of code. One of them is going to get access to the camera. This is from Gum. And the second one is going to be to change the zoom factor of the camera. This will make it easier when I'm doing the demos to see these objects and understand what it is that we're doing, that we're working with here. All right, now that that's taken care of, let's go on to interacting with our strongly typed component and wiring it up. Back over in our character stats runtime, we want to add some variables. So we're going to add variables for the health. Now we're going to actually add two variables, one of them for an internal value for the health and one for the maximum health. Then we're going to add a property. This property will allow us to access health externally outside of this class. It will also allow us to control the health values. All this is going to do is set the health bar percent value, so set that bar's percent, and it's also going to set the label. So if we run these by themselves, we can see that it doesn't look like anything's changing, and that's because we haven't called health to change it. So now what we'll do is we'll actually set these to default values when the program loads. Let's go back to the game, and we'll just set the health to defaults to 100. Now when we run our program, the health bar will be full, and we can see it actually shows the value now, 100%. Let's do the same thing for the mana and the experience. Again, I'm going to have a variable for the internal mana, the maximum mana, and a property so we can access that. And then we can set the bar percentage, the label values. Going to add one for the level, the experience. And then also to store the level of the character. So now I've got the level. I've just created a bunch of variables and properties. That's all I've done. And I've allowed them to link up to the Monogame objects. So this level amount label lives on the character stats runtime. We can see that it's over here. It is a variable or a property that exists on the character stats runtime. So we can scroll down and see that there is a, where is it at? Level label, or level amount label. So now that we've added some more, let's add some more defaults as well. Going back over to game one, I'm just going to go ahead and add those here. And now we're going to run it with those default values. We can see that now we have 100% mana, or 100% health, 25% mana, 0% experience, and we're currently on level 1. Again, this is just a demo, so you obviously wouldn't have buttons here to modify these values, and in fact, right now they do nothing. So think of these buttons to be analogous to actual functions or actions that would happen in your game. When somebody presses the Use Health Potion button, it would interact with the health. If they take damage, it would interact with the health. Same thing with these two buttons for mana, and this one for whenever you gain experience. But the point of this is to show you how to wire up game functionality into this. But we're going to be using these buttons to do that. Let's go back over to our custom strongly typed component. We're going to go into the custom initialize. And what we need to do is we need to say that the health potion button, the click event, whenever we type click, or when we press the button and it clicks, we want to add a method that will handle that click action. So we'll just create a method, we'll call it use health potion. Health potion. Okay. And then we will define that. So go ahead and generate that method for us. Doesn't do anything. Well, what do we want to do when somebody uses a health potion? Let's go ahead and just give them 30% of their health. So whatever the maximum health is, we'll give them 30% of that. Let's test this one button first before we add the other ones. All right? Well, it doesn't seem like it does much, but again, that's because we are at 100%. Let's change that to 20% health so we can actually see that button in action. All right, health potion. Yep, I gained 30%. Click it again. Gain 30 more percent. Click it again. And now I'm at 100%. We need to add in the code for the other ones as well. So let me go ahead and copy and paste those from previous code I've already typed up. And then let's add in those methods that I previously wrote as well. So now we've got a method to apply damage that will be happening when we click the take damage button. We have one for gaining experience, one for using mana, and one for adding mana. Let's go ahead and check out what our program looks like now, what our game looks like. So I want to add some health, I want to take some damage, add some mana, take away some mana, add some experience, get another level. And so now we can see that we can interact with each of these components, and we can write code to do that. I've put all of the code into this class, but it doesn't have to be. We saw that I can also change the values outside of it. I've got an instance of it, and I'm modifying these values to begin with to be set to certain values. Maybe a nice little thing that we could do also is we'd like to make sure that our program or that our character's health regens as one last thing. So in our update method, what we can do is we can say add all this code in. Oops. Let's put this at the top of our program. We'll create an instance, or not really an instance of this, but we'll create a variable at the top. We'll store how long it's been since we've had health regeneration. Just a simple little thing, but to show you a health bar that actually regains health. So now I'm not pressing anything. I'm not using the buttons that are part of Monogame itself is interacting directly with the component to change the health based on a property that I created inside of that class. And the health is going up. I had some questions on previous videos. I try to answer them as they come in. If you have further questions for the things you want to talk about, please bring them up. Thank you for watching this video. Let me know what you want to see in the future topics. I have 2 more videos I'm thinking about making, but if there's comments that talk about a specific thing and give me enough detail to go into that, I'll gladly make a video about what you'd prefer to see instead. Have a good one.